Hi, so in this video we'll be going over a example FRQ from chapter 11. Hopefully doing this FRQ will make you better understand the concepts from this chapter. So we'll be solving this question. So first pause the video and just read the question. Okay, now I'll just assume that you read the question and hopefully you tried it already if you could. We'll get started. So obviously, when we first solve the FRQ, we need to divide our response into 4 sections, which is state, right, and then plan, do, and then conclude. So we'll start by stating the problem that we want to solve, which is basically you need to say which test procedure we're taking, and we also have to talk about the hypothesis since we're doing a statistical test here. And you need to give the alternative hypothesis. So let's go over that first. So we have to say we are conducting a 2-sample, since we're working with the mean and we don't know the population standard deviation or mean, we are working with a t distribution. So I'll just erase this for now. So we have to say we are conducting a 2-sample t-test and then we need to talk about the significance level we're working at with significance level alpha equals 0.01, which is I think that's what's suggested in the question. Yeah. We want to, now you have to state the hypothesis. Test the following hypothesis. Okay, I'll just delete this for now. So now we have to talk about our null hypothesis and our alternative hypothesis. So our null hypothesis is that there is the drug doesn't influence the mean reduction in group B. So we have to say the mean for group A is equal to group B, which is implying that the drug doesn't have any effect. But if the alternate sorry, give me 1 second here. Yeah, but if the drug does have an effect, as in if the drug actually helps reduce cholesterol reading, right, then the mean reduction of group B, which is the group that's using the drug, will have a higher mean reduction than group A. So this is our 2 hypotheses, and now we have to talk about what the values actually mean, where mu A and mu B are population mean reduction in group A and B. So this is what we have to say for state. So right now there are 3 things that you need to say, which is you need to talk about which test you're conducting. So in here we said we're conducting a 2-sample t-test, so that's good. And then we talked about the significance level that we're working at. And then we need to talk about the hypothesis, which are these ones. So we're hitting all 3 check marks for state. And then next one we have to do is plan. So for planning, we have to check 3 things. The first one is random. So obviously this test comes from a random sample. Yeah. I mean, the test is randomly assigned to like the 2 groups. So for random, we can say the subject. Oh yeah, I think I should do this in blue. Yeah, random test subjects were, oh, my bad, were chosen randomly and randomly assigned to the treatment group, as in group A or B. And then the next thing you need to talk about is, well, in this case, we won't really talk about independence. And maybe pause the video and think about why we don't have test independence. The answer is because when you're testing a drug, okay, never mind. You know how like when we were testing 10%, when we are testing independence, we have to use the 10% rule, right? Which is that the sample is less than 10% of the population. Hope you remember this equation right here. But when we are doing this this statistical test, we can have as many samples as we want, right? There are in theory an infinite number of people who can be tested for this cholesterol drug testing thing, right? So in this case, we won't really be checking for independence, but in other cases we would have to check for independence. But in this case, we are not going to do that. So we actually only have to check for randomness and normality. So usually for normality, we have to check if CLT works. And central limit theorem actually does not work here because our sample size for group A is less than 30 and our sample size B is also less than 30, right? So in this case, we have to check we have to actually plot the data points that we have and see if there is any sort of skew or outliers that we have to like take care of. So I'm just gonna like graph it. Just give me 1 second. Yeah. -5, 0, 5, 10, 15, 20, 25, then 30. Yeah, so like you're actually supposed to just manually graph this like that. So just like do it really quickly. By the way, this isn't like completely accurate because I'm just doing it like really quickly, but this should be good to go. Alright, that looks kind of gross, but it's okay. So if you actually graph it, you can say not any significant skewness or outlier is shown, so normality can be assumed. Yeah, so what we're talking about here is that whenever our central limit theorem is not working, as in when the sample size is less than 30, then you need to actually graph the data points and see if there's any skew or outliers. And 100% of the times in AP free response questions, there will not be any skews or outliers, which means that you can just assume normality even though central limit theorem is not met. So that's what we're going to do for planning. And now we have to actually conduct our test. So the equation for two sample t-test is right here. This one. It's this one. Okay. So our t would be, our t-test statistics would be the mean of group A minus mean of group B. One thing to notice here is that I'm using the x bar instead of mu A minus mu B. If you write this, you're going to be wrong because when you are calculating the test statistics, you're working with the data points from the sample, not the population data. And the thing is, you don't know the population data, so it would be wrong to use this symbol. So it's x bar A over minus x bar B, and then in the bottom you have to do square root of standard deviation of group A NA plus standard deviation of group B over NB, which is 10.2 minus 16.4 over square root of 7.66 squared over 10 plus 9.40 squared over 10. Now I'll actually just do the calculation myself. You're supposed to be getting a value of negative 1.62. Yeah, so the equation for test statistics, you just sort of have to remember, just memorize. I think you do get a formula sheet in the test, so you just have to find it and just apply it. So after you actually get that, you have to notice that the degree of freedom for our t distribution would be it's not n-1. You actually can't calculate it yourself, so you would actually have to use your calculator for this. By the way, since you're using a T-Inspire calculator, I think you have to just like learn it yourself on YouTube on how you can just like find how you can just conduct a t-test on your calculator. But yeah, but if you do that, you get a p-value of 0.062. Yeah, I think it's kind of hard for me to like actually like teach you how to find the p-value because I don't know how to use your calculator. Yeah, so you'll have to do that yourself. But let me know if you were able to get this value. Okay, yeah, so if you get 0.062, you have to notice that that is bigger than okay, just give me 1 second. Yeah, so you have to notice that your p-value is actually greater than your significance level of 0.01, which means that since our p-value of 0.062 is bigger than the significance level, which was alpha at 0.01, we fail to reject our null hypothesis. Well, then what was our null hypothesis? We'll go back. Our null hypothesis was that mean reduction in group A, the population mean reduction in group A was the same as population mean reduction in group B. And if that's the case, then we actually have to answer the question, right? Which was, do the data provide convincing evidence that the cholesterol drug is effective in producing a reduction in blah blah blah? So there is no convincing evidence that the cholesterol drug is effective. So we actually have to write that. There is no convincing evidence that the cholesterol drug is effective at the given situation. So I'm just writing that because I don't want to write the whole thing. But yeah, this is how you would solve a two-sample t-test question in FRQ in AP statistics. I hope this helped. If this is confusing, maybe just review it one more, review the concepts one more time, try to do some other questions yourself, and then if you come back to this question, it will make much more sense. So I hope this helped, and see you next time.